Alright. Recording. Alright. Hi guys. So I'll be explaining how to do number 14, lesson 3.6. So in lesson 14, number 14, Bernice pulls a box of like varying forces, right? The box is already moving at this point, and there's a force friction going to the opposite direction of 100 newtons. And we have to rank the speed. And her force graph is shown here, right? And so the important equations, remember, are, in this case, F net is equal to F pull minus F friction, and that F net equals ma. And to start off, what I'd like to do is just draw a straight line at F equals 100 right there, and that represents the force friction. And so what that means is that, as a result, whenever there's no area, there's no box caused because the force friction is equal to force pull. That means that there's going to be no acceleration because F net's going to be 0. When the box is under it, that means that F pull is less than F friction, and so that means this is going to be decelerating, as we've seen from like 1 to 2. And also finally from when it's positive, as you see here from like 2 to 4, it's going to be accelerating, right? And so let's start off with 0. From 0 to 1, you have the same speed, right? Because there's no acceleration. Next, from 1 to 2, 2 is going to be a lesser speed than 1 because it's going to be decelerating, right? I see there. From 3 to 2, you decelerate shown by that box. So then 3 is going to be greater than 2. By 4 to 3, you're also going to be decelerating. So 4 is going to be greater than 3. And finally, from 4 to 5, the speed's going to stay the same because there's no acceleration, right? As seen. And so you end up with these comparisons that I took from my last take. One thing to note is that even though the height here at between 3 and 4 is less than the height from 2 to 3, 4 is still going to be greater than 3 because you don't look at like the whole thing overall. You have to look at from margin to margin, and also because what's added here is then further added to here, right? And so lastly, what we have to look at is whether the speed that's decelerated from 1 to 2 is greater than what's accelerated from 2 to 3, or basically when you return back to the normal, when you return back to initial speed. As seen by the boxes, you're going to be accelerating more from 2 to 3 than you are from 1 to 2, because again there's more F net, and so more acceleration. And so in this case we don't have to worry about that. So what we do know from here is that basically speed 3 is going to be greater than speed 0. And so let's start ranking. We know that speed 2 is going to be the least, so let's call that 1 because that's the lowest. Next up is 0 and 1, so 2, 2. Speed 3, V3 is going to be greater than that. And then V4 is going to be even greater than that because it's going to accelerate more. And 4 and 5 are the same. So you end up with 2, 2, 1, 3, 4, 4. And that's how you do this problem.